Hey guys, we're going to talk about surface area and volume word problems today. So just a reminder to have your notebooks out and write down the work as we go through. So the best way to do it is going to be to watch as I go through each one, then pause the video and then copy down the work. That way you can focus on what's happening the first time without having to worry about writing everything down. Okay, let's go ahead and get started. Number one says Brian is building a sandbox that is 6 feet wide, 3 feet long, and 15 inches high. How many cubic feet of sand will the box hold? So a clue here, they asked how many cubic feet. So if I see cubic, that lets me know that they are asking for volume. So a sandbox would be a rectangular prism. So we're finding the volume of a rectangular prism, which is going to be length times width times height. Now the next thing that I notice is these units are both in feet, but this one is in inches. So we need to convert them all to feet. They asked for the answer in feet. So 15 inches, we can do 15 divided by 12 to see what that would be in terms of feet, which comes out to 1 2500 feet. So we can change 15 inches to 1 2500 feet. So now let's go ahead and multiply length times width times height. So we've got 3 times 6 times 1 2500, which gives us 22 5/10 feet cubed. Okay. All right, number 2. Okay, Adam is building a rectangular planter without a top. The planter will be 7 inches wide, 16 inches long, and 10 inches high. How much wood is needed to make the bottom and sides of the planter? So make sure that you notice that it says there's not going to be a top. So you just need the bottom and the sides. So I went ahead and drew a visual for you here. Okay, and set up your workspace for bottom, front, back, left, and right. Again, remember we do not need to find the area of the top. Okay, so if you will pause the video, okay, go ahead and try this one on your own. Okay, then when you're finished, go ahead and press play and you can come back and see how you did. Okay, so here's our answer and work for number 2. So hopefully you have 572 inches squared. So you can see each of the areas there for the 5 faces that we needed to find. So if you need to pause and go back and make corrections, then go ahead and do that. Okay, next let's go to number 3. Okay. It says gold lining paper is used to cover the inside of a shoebox as shown below. How many square centimeters of gold paper does it take to cover each shoebox? So square centimeters lets me know we're dealing with surface area. Also, if I'm talking about covering something as opposed to filling the inside, which would be volume, but if we're talking about covering, then we know that that's surface area. Okay, so it says that it's covering just the inside, okay, of the box there, so we do not need to include the top. So we've got bottom, front, back, left, and right. Okay, I want you to go ahead and try this one on your own. So pause, get the information down, and then press play again when you're ready to check your answer. Okay, so number 3, the final answer, the surface area of that space was 236 centimeters squared. So here are the areas of each of the faces there. Okay, number 4. Says a wedge of cheese is in the shape of the solid shown below. What is the minimum amount of plastic wrap needed to wrap the cheese? So if we're talking about wrapping the outside of something, then that gives me a clue that we're talking about surface area. Okay, also looking at the 3D figure that we have here, we have a triangular prism. We have 2 congruent triangular faces on the front and back, and then we have 3 rectangles. So let's go ahead and start the process of finding the area of each of those faces. We're going to start with the triangles. Now I know I need to do base times height divided by 2. The base and the height of the triangle have to make a right angle. I see my right angle marking right here, so that's going to be 5 and 12 for the base and the height. So we're going to multiply 5 times 12 and then divide that by 2, which is going to give us 30. Now, by definition, for a prism, we know that the bases are going to be congruent. So that means that the triangles are congruent. So if one of them has an area of 30, then the other one has an area of 30. So I'm going to circle the area of each face as I go through. Now, moving on to the rectangles, and I just labeled this R1, R2, and R3 for rectangle 1, 2, and 3. So let's start with this one on the bottom here, and it looks like the dimensions are 13 and 10. So we're going to multiply 13 times 10, which gives us 130. Okay, rectangle 2, let's look at this one on the top right side, and it looks like it's 10 by 12. So we're going to multiply 10 times 12, which is 120. And then rectangle 3 is this one over on the left side, and it looks like it's 5 by 10. So we're going to multiply 5 times 10, which gives us 50. Excuse me. Then we're going to add all of those faces together. So I'm going to go back and pick up those numbers that I circled. So I've got 30 for both of the triangles, and then the rectangles were 130, 120, and 50. And so adding those up, we get 360 centimeters squared. Okay. All right, number 5, I'm going to let you try this one on your own, but first we'll read through it together. It says, Scott is building a ramp out of plywood sheets as shown below. If each sheet of plywood is 25 square feet, how many sheets will Scott need to buy to build the entire ramp? First of all, I see square feet, which lets me know that we're dealing with area, or more specifically in this case, surface area. So if he's building the ramp, he's not going to fill the inside of it. He's just going to be using the wood to make the faces, the 5 faces on the outside. So this is definitely not volume because the inside of it is going to be hollow. So this is surface area. Now the question doesn't specifically ask just what is the surface area. That's the first thing that you're going to need to find. So you have the 2 congruent triangles, then you have your 3 rectangles. Once you add all of those answers up and you get your final surface area of the whole figure, let me give you a hint before you try it here. So then you're going to do the surface area divided by what the surface area of 1 sheet of plywood is. So once you get your surface area answer, divide it by 25, and then that will let us know how many sheets we need to buy. So go ahead and pause, try that one on your own, then press play when you're ready to check your answer. Okay, so the area of each of the triangles was 24. The rectangles were 136.8, 171, and 102.6. Adding those all together, the total surface area was 458 4/10 feet squared. Then we need to divide that by what the surface area of 1 sheet of plywood is. That gives us 18 336 thousandths. Well, when you go to the store, they're not going to let you buy part of a sheet of plywood. So in this case, we would need to round up and buy 19 sheets of plywood, and then we would just have some left over. So final answer is 19 sheets. Okay, number 6 says find the total surface area of the Rubik's Cube. Now the one thing that's a little different about this one is I don't see any specific measurements like feet or centimeters. So we're just going to call each of these little squares just a unit, just kind of a generic term. So let's look at one face here. So we've got 1, 2, 3 by 1, 2, 3. It's a perfect square, 3 by 3. So the area of one of those faces is 9 units squared. They're 9 little squares, literally. Now, if it's a cube, we know that there are 6 faces, so then we're going to multiply that by 6 as a shortcut. We don't need to add the number 9 6 times. We can just multiply by 6. And so the total surface area is going to be 54 units squared. So that's how many total little squares there are all around the outside of the figure. Okay, number 7, Beth is staining all 6 sides of a barn door. So that lets me know she's including all 6 faces. If 1 pint of stain covers 562 square inches, that's a hint that I'm dealing with surface area. How many cans of stain will she need? Okay, so the first step is going to be to find the surface area. I've gone ahead and set up kind of your format and your workspace there, front, back, top, bottom, left, right. Okay, this is similar to one of the previous questions we just did, where once you know the total surface area, you are going to divide that by the number of square inches that 1 pint of stain will cover. So you're going to do your surface area divided by 562 to get your final answer. So pause, try that one on your own, and then press play when you're ready to check. Okay, so we had some pretty large numbers here to work with. The front and the back came out to have an area of 88,800. The top and the bottom were each 444 square inches. The left and right faces were 1,800 each. Then I need to add all 6 of those numbers, and I went ahead and kind of grouped them together just so I would have some smaller numbers to work with in the calculator. But adding all 6 of those faces, the total surface area is 182,088 square inches. Then we're going to divide that by 562, and it comes out to a perfect whole number. So we need 324 cans of stain. Okay, so that's it for our lesson on word problems. Email your teacher if you have any questions. Have a good day, guys. Bye.